Today we're going to be introducing three more trig functions, and these trig functions are the reciprocals of the three trig functions that we already know. So the ones we've already talked about have been the sine of theta, which we know when it's sine, it's opposite over hypotenuse, cosine of theta, which is adjacent over hypotenuse, and then tangent theta, which is opposite over adjacent. For the three trig reciprocal functions, the reciprocal function of sine, which is 1 over sine, is going to be cosecant theta. And if sine theta is opposite over hypotenuse, then cosecant theta is going to be hypotenuse over opposite. The reciprocal function for cosine, the reciprocal is 1 over cosine, and that is going to be secant. So secant theta, and if we take the reciprocal of adjacent over hypotenuse, we will end up with hypotenuse over adjacent. And then the tangent, the reciprocal of that is going to be cotangent. So cotangent theta, and if tangent is opposite over adjacent, then cotangent is adjacent over opposite. So I technically remember the first three trig ratios that we talked about, and then in my head I do the reciprocal of them. So I know that cosecant and sine are reciprocals, and then I just take the opposite over hypotenuse and I flip it hypotenuse over opposite for cosecant, and so on. So if we take a look at our triangle in example number 1, we can see that in this example we have a triangle, and they want us to find each of the following, and they're talking about angles B and C, the secant, cosecant, and cotangent of each of them. So in my triangle, I have a missing side over here that I don't know the length of. So I'm going to use Pythagorean theorem to find that missing side length before I do anything else. So this is going to be 5 squared plus 7 squared equals x squared. So 25 plus 49 equals x squared. So 74 equals x squared. And then when I square root, I end up with x being equal to plus or minus the square root of 74. And in this case, we only want the positive value. So it's the square root of 74. So our x value is the square root of 74. So when I start working my way through each of these choices here, I'm going to separate this into two different sections. The first thing that I'm going to talk about is everything that has to do with angle B. So I'm going to put my focus on angle B. With respect to angle B, this is the opposite, the adjacent, and the hypotenuse. I know that secant for part A is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then that means that secant is hypotenuse over adjacent. So when I go through then, for the secant of B, it's going to be radical 74 over the adjacent side, which is 5. For cosecant, for part D, I know that that is the reciprocal of sine, and sine is opposite over hypotenuse, so this will be hypotenuse over opposite. When I take a look at my triangle, I've identified that radical 74 is the hypotenuse, and in this case the opposite side is 7. Going on to part C, the cotangent of B, I think back to tangent, and tangent is opposite over adjacent, so cotangent is the reciprocal, adjacent over opposite. So the cotangent of angle B is going to be 5 over 7 for adjacent over opposite. Now I'm going to go back and do the same exact thing, but I'm going to use angle C for this one. So with angle C, which I have in parts B, C, and E, angle C is here. which means that this side is now the opposite, this side is now the adjacent, and this side is still the hypotenuse. For cosecant, which I have in part B, it's the opposite of sine. Sine is opposite over hypotenuse, so this is hypotenuse over opposite. So when I go through and sub in the information that I have, hypotenuse is radical 74 over opposite, which is 5. For part C, it's cotangent of angle C. That's the reciprocal of tangent. And I know tangent is opposite over adjacent. So this has to be adjacent over opposite. So the cotangent of C is going to be 5. I'm sorry, I take that back. It is going to be 7 over 5. And then moving on to angle C, the secant of angle C, I know is the reciprocal of cosine, and cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent. So the secant of C is radical 74 over 7. If I move on and I take a look at example number 2, there's no triangle for this one, but they do tell me that the sine of theta is radical 2 over 2. And they ask me what I know about the cosecant of theta. What I want to remember is that cosecant and sine are reciprocals. So if the sine of theta is radical 2 over 2, that means that the cosecant of theta is going to be the reciprocal of that. So I want to flip that upside down. Of course, we're not allowed to leave that radical in the denominator, so I'm going to multiply top and bottom by radical 2. Which will give me that cosecant theta is equal to 2 radical 2 over 2, which then simplifies to cosecant theta equals the square root of 2. It does also ask me what the value is of theta. So in this case, if I'm solving for theta, I want to do inverse cosecant of radical 2. Because our calculator does not have a cosecant button on it, the way that I generally look at this is I convert it back into a sine equation because I can use that on the calculator, which means I'm looking for sine inverse instead of cosine, and I'm going to go back to the original sine value, radical 2 over 2. And when I type that in on the calculator, that second sine, radical 2 over 2, I find out the sine is equal to 45 degrees. For question number 3, it tells me that the exact value of cosine 30 is radical 3 over 2, and it wants the exact value of the secant of 30. Again, cosine and secant are reciprocal functions, so if the cosine of 30 is one fraction, then the secant of 30 is its reciprocal, so 2 over radical 3. Again, we're not allowed to leave the radical in the denominator, so I need to multiply top and bottom by radical 3, which will give me secant theta equals 2 radical 3 over 3 for my final answer. When it says exact value, it is implying that there should not be any decimals in there. You keep the radicals there. The next section is asking us to go through and express each of the following in terms of sine or cosine and as a single fraction. So there's a little bit of algebra that's involved in this. We need to make sure that you're relatively comfortable with that. So for question number 4A, I'm not allowed to leave a secant in there because the directions tell me I have to use sine and cosine. So I'm going to turn the secant into its reciprocal, which is 1 over cosine theta. It tells me that this has to be a single term. That means that I have to find a way to combine these two terms together. I'm going to give the 1 a denominator of 1, and then in order to put them together, they have to have a common denominator. So what I need to do in this case is say, well, what would the common denominator be for those two fractions? And if I look at the denominator of 1 and the denominator of cosine theta, the common denominator is going to be cosine theta. When I go back now and I look and I say, well, what do I need to multiply the first fraction by to create a denominator of cosine theta? I can see that what I have to multiply by is a cosine theta. So over here, I'm going to multiply a cosine theta on the bottom, and whatever I multiply the bottom by, I have to multiply the top by. So when I do that, on the top, I end up with cosine theta. One thing that you want to keep in mind is when you're here, this part of the fraction should be able to reduce back to what you had initially. And initially, I had a 1 here, and it is true that cosine theta divided by cosine theta is 1. For the second fraction that I'm subtracting here, it already has a denominator of cosine theta, so I don't need to make any changes to the numerator. Now that my denominators are common, I can go through and subtract the fractions. On the top, I have cosine theta minus 1. On the bottom, cosine theta. So this is considered more simplified in the sense that it is written in terms of sine and or cosine, in this case cosine. For part B, we're going to do the same thing. In part B, I'm changing everything over to sines and cosines. So in here, I know that on the top of my fraction, I have secant, and secant is the reciprocal of cosine. So wherever I see secant theta, I can put 1 over cosine theta. On the bottom of this fraction, I have a cosecant theta. Its reciprocal is sine. So in place of cosecant, I can put 1 over sine theta. And then from this point on, I'm going to treat the middle fraction bar as a division, which means that I technically have 1 over cosine theta divided by 1 over sine theta. And our rule is that 1 over cosine, when we divide, change the division to multiplication and do the reciprocal. And then when I multiply across, I end up with sine theta over cosine theta. Now, if you take a look back at your beginning of your notes, so I'm going to go back a page. One other thing that I want to point out to you is that tangent of theta, in addition to being equal to the opposite over the adjacent, is also equal to sine theta over cosine theta. So as a rule, tangent is equal to sine over cosine. With that being true, if we go now and we take a look at what cotangent is, if it's the reciprocal, then we know that cotangent must be cosine theta over sine theta. So this is another way for us to go through and define the tangent and the cotangent when we're looking at that. So if I go back now to that last question that we were working on, in this last question, we can see that technically if they had said that we were only allowed in our directions to represent this in terms of one trig function, if that was what our directions were, then we would have to take this one step further and turn this into the tangent of theta. So they expect you to know that. For this particular question, though, we wouldn't do that because they say in terms of sine or cosine as a single fraction. So I've got a single fraction here, a numerator and a denominator with sine and cosine in it. So you kind of have to watch your wording here. Pay attention to what it is that they're asking you to do. There are some times when you need to convert the sine over cosine into the tangent.